Okay, we're going to look at integration by parts today. This is our formula for integration by parts. All your problems are going to be given to you in this form here of a u times a dv with your integral sign in front. What you're going to have to decide on is which part is the u and which part's the dv. Your formula then is you need to take u times v minus the integral of a v du. So for our particular problem here, you need to go ahead and try to figure out, okay, which part do we have down here matches with which part up here? Well, it's likely that your dx is going to correspond to your dy, or dv, sorry about that, and therefore your ln of x would have to correspond to your u. And well, that's exactly what we are doing over here. Well, when you have that, you then need to go ahead and for your formula, you need to have a u times a v. Well, if you have u, you also need to get v. And all we know is a dv dx. But to go from a dv to a v, you have to integrate. And well, when you integrate your 1 dx, you just get an x. So you plug in your u, plug in your v. We now have this first part. Then you got to go minus the integral of your v. Well, we already figured in our v, or figured out our v, not figured in. And then you need to go ahead and figure out your du. Well, you know u is the natural log of x. So your du, to go from u to du, you take your derivative. So you know it's 1 over x times dx. So then that goes in down here for your du. Now, you know you're on the right track if the part that's after your integral sign right here is easier to work with than what you started out with up here. Well, we have our x natural log of x. You'll notice after your integral sign, your x natural log of x is a 1. It's pretty easy to integrate your 1 dx, and that's just an x. Since it's an indefinite integral, you know you're going to have a plus c. So where does the integration by parts come from? Well, you guys all know your product rule for differentiation. We've talked about that for months now. Well, if you integrate both sides of your product rule, you'd have the integral of your derivative, the integral of the first part, plus the integral of the last part. Well, when you integrate your derivative here, these two really undo each other, and so you're just left with u dv equaling this stuff here. Well, if you go ahead and get this right here by itself, that's what we're doing here, by subtracting this from each side, you get your integration by parts formula. So it's really just from integrating your product rule. Okay. Now, here's your arc sign of dx that you're integrating. So you need to figure out, well, what part up here, since we have really two parts, only two parts, what's in front of the multiplication sign, what's afterwards. I'm going to assume that the dx is my dv, and therefore the u has to be what's in front of the multiplication sign. Then you want to go ahead and you have to figure out v, so you got to integrate here. Then you have to take your derivative of this, and you get this here, which is on the next page of your notes, the derivative of your arc sign. It's in a box in your notes. We can also go ahead and work that out, but we'll just go with this for now. So we'll take your u times your v. Your u is your arc sign. Your v is your x. So that's what we have. Then you got to go minus your v, which once again is your x, so we're just plugging stuff in. Then you got to go your du. Well, your du is just this big ugly mess thing right here. So we have an x, arc sign of x, minus this integral. Well, this integral, you could just use your u substitution. You could say, oh, well, u is going to be the stuff inside my root. Well, then your du is a negative 2 x dx. But you'll notice that you don't have a negative 2 hanging around, so you got to multiply both sides by negative 1/2. So we really have the very first part up here we're not doing anything with, other than I'm putting the x in front. Then all we're doing is your u substitution on this. Well, when you're integrating that, using your u substitution, it's really just a negative u to the negative 1/2, because this is 1 over root u. Your du is at negative 1/2 du, which you put the negative in front. Integrate, you get negative u to the 1/2, or negative root of a 1 minus x squared plus c. That's what we're putting in here for this whole part right here. What we just worked out was the negative root. But you notice it's a positive here because you got to subtract your negative root, which ends up being positive. Okay. Now we need to go ahead and do this one here. Well, we could say u is going to be the e to the x, negative x, and so dv would be your x. So therefore, you'd have to integrate to get your v. So you get a 1/2 x squared. You have to differentiate over here. And well, then when you use your integration by parts formula here, you got to go your u times your v, your v, minus the integral of your v, this part right here, times your du, which is this. Well, when you simplify this down, just taking the half to the front, and this here, that negative undoes that negative, making it positive. Now, you'll notice that what we have here for your integral looks worse than what we started out with. So that means we didn't choose the right stuff to begin with. So we got to go back and retry it. So we'll go ahead, start with a different u and dv. Basically, we're going to switch them and then see what happens. So we have to figure out your v, so you have to integrate. You have to figure out your du, so you have to differentiate. Now we'll go ahead and try your integration. Now we try that integration by parts formula. So we'll go our u times our v, minus the integral of our v times our du. So we just have our negative x, e to the negative x. That negative undoes that, so we just have the integral of our e to the negative x, which ends up being this, plus our c. If you wanted, you could go ahead and pull out your common factor, or you could leave it like this. Doesn't make a difference. Then we get to the fun one, but we'll do that on the next video.